Can? Now, let us recall. Ziguan, what's your homework? Let us recall the simple interest formula. Okay? Simple interest. Principal times the rate times the time over 100. Okay, this is not given. So you must memorize. Must memorize. Okay, where P is your principal, the amount of money that you started off with. R will be the rate, and T will be the number of years. Okay, so now the bank is going to pay 5%. Take note that 5% refers to 5 over 100. That's 5%. In addition, our value of R over here equals to 5. So from that very first portion, we know the value of R, we know that it's going to be 5%. And this $2,000 refers to the principal. Must understand the question, then you can apply the formula. Then how much will he have in the account? How much money? So this portion, how much money, refers to principal plus interest. Because they didn't ask how much he got extra. They didn't ask about principal or interest only. They asked how much altogether in the bank. So it must be the original plus whatever he earned as interest. Okay, at the end of the fifth year. So P refers to 5. Okay, so right now we are able to substitute the information back into the formula. So interest. Okay, starting with P. P has a value of 2,000. So 2,000. R has a value of 5. So that is 5. T has a value of, shall we return here? T equals to 5. The fifth year. So we have another 5. And all these divided by 100. Because that is the formula. Why is there a division by 100? It came from R over 100, which is our 5%. This portion. Can you see the green color highlighted first? All three of them mean the same thing. R over 100 is R%. 5 over 100 is 5%. Okay? Yes, any questions? Okay, so if you were to Google search, you might see interest such as written as I equals to PRT. Just like that. Is that what you saw? Is this what you saw? No, huh? Okay, then you go and check it out again and show it to me, can? But this is the compound interest formula which we are not using. Some variations are like this, but I don't want to confuse you. So we just stick to this, PRT over 100. So this over here, based on our calculation, it is going to be just the interest. So 20 times 25. So we get $500 as interest. Hey, so by putting money, $2,000 in the bank, he earns $500 over 5 years. Very good deal. So total must be our original $2,000 plus the 500 to give us $2,500. Okay not? Not you lah. You got okay not? Why you look so stoned? Why you look so stoned? Haven't opened the book. Okay, next question. 6. Ali, now he deposits Ali more money, $20,000 in the bank account. And this is our principal. P again. The money is left in the bank for 3 years. Okay, that is our duration, 3 years. Earning compound interest. Now, compound interest has a different formula that you don't need to memorize. Compound interest formula looks like this. AN equals to P. 1 plus R over 100 n. Alright, so this over here, given. No need to memorize. So no need to memorize is a good thing, right? It's given to you. However, if you don't know how to use it, then it's as good as not giving it to you. So we need to know how to use it. What does AN refer to? AN equals to total amount, which is principal plus interest. Okay, AN, principal plus interest. So P, principal, R equals to interest rate without the percent. That means just the number over here, 1. Okay, this part may be confusing, but if you remember what I always tell you, every time you see the percent change to over 100, and then you see the over 100 over here because it is already in percent form. Okay, so R is the interest rate without that percent sign. Then the last one, N, will be, you can treat it as the time in years. Okay? So in our simple interest formula, they use T, capital T for the number of years. In this case, they use N. I would like to use T for you, but it is given to you as N. So if I teach you T, then you open the formula list, oh, what is this N? Then you don't know how to use. Then it's useless. So you must know what all these mean. Okay, this is what's going to be given. The formula is given to us. It is called compound interest. Formula. Different from simple interest. They are different things. Okay, now that we have all this information, our 3 years refers to the value N. The 1 over here, 1 equals to our R value. And then, they just want the total interest earned in 3 years. So let us substitute everything into our formula. N. N has the value of 3. So after 3 years, the total value will be P. The value of P is 20,000. Rich guy. Open bracket, copy down the 1. No change. Plus R. R has a value of 1. 1 over 100, no change. The power N. N will be 3. As simple as this, we key it into our calculator. And we get 20606.02.
Then minus.
Okay, hang on. Do you think this is the final answer?
No.
What is this actually?
This one is the amount.
This is the total, right? This is the principal plus interest. I need you all to have a feeling about numbers and money. Does it sound reasonable? You put in $20,000. Imagine, wow, a lot of money, $20,000 put in the bank. After 3 years, the bank give you extra $20,600. I wish, right? Cannot be one. They won't give you the same amount and even more than your principal after 3 years.
Yeah, not that.
Yeah, they're not dumb. They cannot give you so much extra money. How do you make all the money come out? Right. Okay, so this is actually our principal plus interest. So in order to find the interest only, we need to use 20,606.02 minus your original principal. And you get 606.02. Now this is reasonable. You put in 20,000 in there, they say, okay, after 3 years, I make your money grow for you. And I give you extra $600.
What did earn?
What did they earn? They didn't just make $600 from your $20,000. You give the bank $20,000, right? They go and invest. They do a lot of things with your money. Then from your $20,000, maybe they make $1,000 over 3 years. Then $1,000 extra, right? $600 I give you. You happy? I happy. I earn $400. You earn $600. That $1,000 could not have come out of thin air, then $1,000 needed to be generated from your $20,000. So your contribution is $20,000. My contribution is my expertise. I invest for, I grow your money for you. Then your benefit is $600. My benefit is $400. Okay? So that's how investments like this, for example, work. If the investment did not go well, then it depends on the contract that you have with the bank. If it is a fixed interest that you will be getting, then you don't care about whether the bank make money or lose money. They have to pay you. Okay? Hopefully not. Okay, next one. Calculate the following. Okay, this should be very simple. 8 plus 81. So that is 89. Or you can just use your calculator. So 3 power 3, that is 27 times what? 5 power 4. 625. And we get 16875. Next. Calculate decimal, 2 decimal places. Okay, so the first one. Oh, what is this? This is 2 to the power negative 3. You can just key in your calculator. 2 power negative 3 and minus 2 power 5. Okay. Then change it to a decimal, we get negative 31.875. But since they wanted it in 2 decimal places, you circle the 3rd decimal place. It's just like your significant figures. If I want 2 significant figures, you circle the 3rd significant figure. If I want 2 decimal place, you circle the 3rd decimal place, and then you decide, look at what you have circled. Should I increase the previous number or should I let it be? So since I circled a 5, I have to increase the previous number. And now it is rounded off to become negative 31.88. Alright, next one. 4 power negative 2. And is this a plus or divide? Divide, okay. Divide by 3 power negative 3. Answer, 27 over 16. So this value is 1.6875. Since they want 2 decimal place, I find the 3rd decimal place. They want 2, I look for number 3. 1, 2, 3. Circle. Since it is a 5, 6, 7, 8, 9, I need to increase the previous value. You give me 1.69. Next page. Write each number in standard form. I think we started our sec 3 with standard form, right? Or indices, okay? So must recap, all these things very important. Correct to 2 significant figures. So standard form first, then change to 2SF. So for our standard form, we need to search for the decimal place all the time. Search for the decimal place. So in part B, I can see the decimal point. In part A, where's the decimal point? It is over here. Okay, draw your decimal point. It is at the end. Now we have to move the decimal point, and as we move, we need to count. We need to move it until it is between 2 numbers where the first number is more than 0. Just jump, 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 jump until it goes between 2 numbers where the first number is more than 0. Okay? So let's go jumping. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we stop over here. We jump 9 times. So this has a value of 7.028. Now question, do I still need to write all the zeros at the back?
No.
Do I need to write all these zeros?
No need.
No need, because our decimal point is over here now. So all the zeros at the back they are not required. So then you look at this again. Hey, are these really the same? Is the original number really the same as what you have written?
No.
They are very different. This number,
10 power.
if you see in a bank, you can retire already. You can support your future, 5, 6, 7 generations already. This is $7 billion. $7 billion, a lot of money. But if you open your bank account, you see $7.03, then you're very sad. Okay? Very, very different. So you cannot say that they are equal. Therefore, we need to times 10 to the power of, is it 9 or negative 9?
9.
So you have to decide. You can do so by using your calculator to check it out also. Now 10 power 9 is a very big number. So it makes sense for it to be 10 power 9. This is a very big number. It is actually 1 billion. Okay? So power negative 9 is very small. So our answer is 7.028 times 10 power 9. And now we need to go to the second part. It says two significant figures. Early on they wanted two decimal places, so you circle the third decimal place. Now they want two significant figures, you circle the third significant figure. So let's count. This is my first significant figure, first SF. This is number 2, and DSF, and this is number 3, third SF. So I must now circle my third SF. So I look at it. Is it a 5, 6, 7, 8, 9? If it is 5, 6, 7, 8, 9, I need to draw up arrow. But since it is a 0, 1, 2, 3, 4, I leave it. Okay, and I just ignore the whatever I circled. And this is rounded off to become 7.0 times 10 to the power of 9. At this point, you may be thinking, hey, Mr. Wong, just now you said that all the zeros after the decimal place don't need to write. Then why are you writing this? The reason is because they wanted two significant figures. You cannot just leave your answer as 7 times 10 to the power 9, because this is only one SF. Okay, we need 2, so we need to have 7.0. Okay, we'll do the same for part B. Same approach. Find the decimal point and start jumping. Jump until it goes between two numbers where the first number is more than 0. So let's jump to the right this time. 1, 2, 3. And we see the number as 5.67. Then you don't stop here. You look at it again. Hey, is 0.00567 the same as 5.67? No, they are very different. The original number is a very small number. It is less than 1 cent if we are talking about dollars. Whereas this is $5.67. So they are not the same. So likewise, we need to multiply by 10 to the power of something. So earlier we jumped 3 times. 3 times. So is it 3 or negative 3? Then you have to decide. Now 10 to the power of 3, this is a big number. This is 1,000. 5.67 times 1,000 will be $5,670, which is different from the original question. So it cannot be power 3. And then leaves us with power minus 3. So here we have power negative 3. And you can check using our calculator very easily. 5.67 times 10 power negative 3. You get back the same number as the question, 0.00567. Okay? From here, we still need to round it off to two significant figures. So you count the third significant figure. This is number 1, number 2, number 3. Circle it. Since it is a 5, 6, 7, 8, 9, we need to draw up arrow and we round it off to become 5.7 times 10 to the power negative 3. Okay? Wow, okay, so we see very huge numbers over here. And that is where our standard form becomes useful for us. So write this humongous number in standard form. Let us find the decimal place. The decimal point, it is right at the end. Over here. So start jumping. Okay, all of you start jumping now and tell me what you count it to be. Okay, finish already? Let's ask Aloysius. How many times did we jump? Oh, okay. So this is 1.08. I don't need to write the rest of the zeros already. So this is times 10 to the power. Is it positive 12 or negative 12? Okay, let's ask Sarah. Positive 12 or negative 12? Huh? Negative, okay. Oh, she said positive. Okay, yeah, correct, positive. Okay, so this is positive 12. It's a very big number. So now that we have written it in standard form, they still want it to be two significant figures. So I circle the third significant figure. And since it is a 5, 6, 7, 8, 9, I draw up arrow and it is round off to become 1.1 times 10 to the power of 12. So look, such a big number, instead of writing so many zeros, it is just simplified to this. Much easier to work with, much easier to key in your calculator. Okay, now the speed of light, 3 times 10 to the power 8 meters per second, write it in ordinary form. So this portion, ordinary form, is like the opposite of our standard form. That means the usual way that we write things. And it is very easy to do so. All we need to do is to just use calculator. That's all. Okay, so what do we have? 3 times 10 to the power 8 equals to, then press 3 times 10 power 8. And then you be very careful when you count. How many zeros do you think there are? 8 lor. Okay, if you understand it properly already, it is just 1, 2, 2, 3, 1, 2, 3. This 10 power 8 means 2, 3, 4, 5, 6, 7, 8. And that's what it means. 10 power 8 is 1 with 8 zeros. Just like your 10 power 2. What's 10 squared? 100. There are 2 zeros. What's 10 power 3? That is 1000. There are 3 zeros. What about 10 power 5? Then there are 5 zeros. 10 power 8, 8 zeros. Okay? Next page. Okay. Number of chairs made in one day directly proportional to the number of workers in making it. So this sentence, this means that the more workers, the more chairs are made. Logical? Logical, right? More workers, more chairs made lah. Okay. 4 workers can make 20 chairs in one day. How many chairs can 10 workers make? So this is how we're going to do it. 4 workers. Cannot be equal. You can say represent or you can say make 20 chairs. What do you think I should write at the bottom? Or 10 workers. Make. Okay, some of you very familiar already. What do you think I'm going to do next? Draw the arrow lah. Divide. So you see, I've been doing this all the time because it is very useful. So this is the division. 20 over 4. But that's not all. We still need to multiply by 10. Times 10. And they can make 50 chairs. Okay? So look, written like this, I don't even need to write statements anymore because it is very clear. 10 workers make 50 chairs. Very short. Very clear. Using the same structure. Okay, on the left hand side we have workers and workers. On the right hand side we have chairs and chairs. Okay, now, question 2. Now it is slightly different. Time taken to complete a job is inversely proportional. This word over here, compare it to this word, this phrase. Directly proportional and inversely proportional. They're like the opposite. So what is happening over here? Time taken is inversely proportional to the number of men doing it. The more people work on the same job, the less time you need. So this is the difference. in the past, the previous question, the more people working, the more chairs you have. Now, the more people working, the less time is required. So it is the opposite. They call it inversely proportional. So 4 men need 80 hours to finish the job. Let's write that down again. 4 men need, you can write represent, need 80 hours. Okay? Now, they are asking for 10 men. Need, okay, look, the structure is the same, right? So if you have been very good students, you might be thinking, okay, let us do a divide, and then we do a times. Don't copy this yet. Don't copy, this is wrong. Let's see what's going to happen if we do that. 80 divided by 4. 80 over 4 times 10. We get 200 hours. Does this make sense to you? Cannot be, right? 4 men need 80 hours. Well, I have more people there, I need more time to finish it. Cannot be. Something is wrong over here. What is wrong? Because it is inversely proportional. So we cannot use this. Whatever I taught you over here works a lot of times because most of the questions are directly proportional. Today this is inversely proportional. I cannot do this. Okay, so what is how then should we do this? So we want to find 10 men. We are going to use logic. We bring it down to 1 man. Need. How long? Hey, if 4 men need 80 hours, then 3 of them MC. Then 1 person need how long to do it? Think? There is a job that requires 4 people, total 80 hours to finish it. Okay? 3 people MC, left with 1 person only. He has to finish everything. Do you think he takes less than 80 hours or more?
More.
Has to be more, right? Is it going to be exactly 80 or 81 or even bigger? Even bigger. Okay, so we need to decide how much is it going to be?
80 times 4.
80 times 4. Is that logical to you? Because he has to take over other people's job, right? So 1 man will need 80 times 4 equals to 320 hours. Wow, poor thing. Okay, so it is a 320 hour job. 1 person has to finish it. But if he asks his friend, come and help me, then they take less time. If 3 friends come and help, total 4 people, then they only need 80 hours. But if he has more friends, he say, okay, 10 men.
Divide by 10.
Need how long this time?
32 hours.
So yeah, divide by 10, right? Isn't it logical? So it is a 320 hour job for 1 person. If he has 9 other friends coming to help, total 10 people, then we divide by 10. 320 over 10 equals to 32 hours. 10 men need 32 hours. Then look back, is it logical? 4 people need 80 hours. 10 people must be less time lah. 32 hours only. Okay? So I've shown you how we go about thinking. Using our same method, the directly proportional doesn't make sense. We end up 1 man need 200 hours. Cannot be. Then, so 1 man requires, what did we say? 20 hours. That cannot be true. So we have to look at it again. Oh, it's inversely proportional. So we use this logical statements like this to help us do the question. Okay, your mid-year exam, which is the same format as your end of year, your prelims, which is the same as your N levels, 2 papers. 1 paper, paper 1, 50 marks, 1.5 hours. Paper 2, 50 marks, also 1.5 hours. Okay, let's talk about paper 1. You need 1.5 hours to finish 50 marks by yourself. If the whole class work together, everybody do like 1 question. How long do you need to finish the paper? It's going to be less than 1.5 hours, right? So it is it is a similar case over here. Originally, 1 person requires 1.5 hours to finish the paper. If the whole class, everybody do a bit, then we're going to spend like less than 10 minutes to finish the whole paper already. Okay? Now, question 3, y is inversely proportional to z. Now there isn't a situation of how many men, whatever already. Y is inversely proportional to Z. We write it this way: Y equals to K over Z. Okay, please write this down first. Y is inversely proportional to Z. Y equals to K over Z. One way. This means Y is inversely proportional this part. And then Z is at the bottom lah. Y is inversely proportional to Z. When Y has a certain value, Z equals to 10. Sorry? K. K is an unknown that we are gonna have to that we need to solve this question. Okay? So there is this relationship. This is just like our earlier question. The time required is inversely proportional to the number of men that we have. The more men we have, the less time required. Okay, when Y has a certain value, Z equals to 10. Okay, so we write down a certain value. So let's call it Y1. This is our certain value. A certain value. That is our Y1. When Y has a certain value, then we have K, which is a constant. I don't know what K is yet. Divided by Z. Z has the value of 10. Okay, I'll just highlight to show you where I am. This portion, they're the same thing. Y is inversely proportional to Z. Then the next line is when Y has a certain value, Z equals to 10. That is this line. Find the value of Z when Y is half. We're going to make Y, this Y1, we're going to divide it by 2. What is going to happen to our value of Z? Rather find the value of Z. Okay, so now Ahmad asks, what is K? We have to make K the subject. Now we can say K equals to 10Y1. We are trying to find out what K is. Okay? K has the value of 10 times Y1. I don't know what Y1 is. They just told me it's a certain value. Just put it down as 10Y1. Then we're going to put this back inside here. Okay? No X. The question don't have X. So it's just, oh, you mean instead of K you want to use X, is it? You can lah. But usually we use K. So let's substitute it back into the original equation. We end up with Y equals to K. K is our 10 Y1 over Z. Okay, now this is our new equation. What did they say? Find the value of Z. That means they want this. When Y is half. This Y doesn't stay as Y. Originally, we had a certain value of Y1, right? And now we're going to halve it. We're going to divide it by 2. So this Y becomes Y1 over 2. And we want to find the Z over there. Okay? So I have a fraction equal to fraction. I want to find Z. Cross, yes. So what do we have? Z times Y1 equals to 2 times 10 Y1. So we cross, we wanted to find Z. So I need to divide both sides by Y1. Z now equals to 20 Y1 over Y1, which is 20. Why not YZ? What do you mean? Oh yeah, you can put or Y1Z. They're the same thing. Okay, then Aldrich say, I don't understand. Right? I suppose quite a number of you also don't understand. Let me think about this after the lesson. I think how else I can simplify it for you further. Yes?
Do like that.
Olivia has a suggestion.
No. I know. My teacher didn't teach.
But where the 4 come from?
I know.
Yeah, so cannot.
Oh,
Wait, the black color one, right?
yeah.
Yes. Okay, can. Anybody got a better way of presenting? I mean, this is how I taught my previous Sec 4 students lah. I will try and think if there's an easier way to present this. But if you have a suggestion, please let me know. Okay?
Oh, no.
What's the question to have 4? Okay, so let's move on to the next question first. Next page. Okay, again our Sec 3 work. Map is drawn to a scale 1 to 20,000. So, write down map and actual. 1, 20,000. So part A, distance between the 2 taxi stands is 6 cm. On the map, what is the actual distance in meters between the taxi stand? So what do we have over here?
120,000.
Times 6 times 6.
120,000.
Correct. So 120,000 cm. So they want the actual distance, but it is in meters. Distance equals to 1200 meters. Because we just need to divide by another 100. So 1200 meters is the same as 1.2 kilometers. Okay, now the next part, B. For part B, we have the same scale. Map, actual. 1 to 20,000. Now they tell us that the distance between the 2 bus stops is 800 meters. Actual will be 800 meters. What is the distance in centimeters on the map? So how do we go from,
So I change to meter.
you change the 20,000 to meters, is it? Can.
Here.
Can. Okay, so you see, from here to here, multiply by what or divide by what? A bit more complex. So it may be easier for you to change your either 800 meter to 800 cm, meter 800 meter to cm, or you change your write down the 20,000 as either meters or cm first. Okay? So I think since the question wants it in cm for the map, they wanted it in cm, I can change my 800 meters to cm also. So the 800 meters will be,
But the number is bigger, so it's high.
is it? So what do you do?
I change it to 200 meter and then times 4.
Okay. Yeah, actually, Nivea has a better suggestion. So you see, initially we could have written 1 cm to 20,000 cm. We can write that. We can also write 1 meter to 20,000 meter, but not as useful. We can also write 1 km to 20,000 km, but not as useful. So if we had written cm and cm over here, then what we have on the right hand side will be 200 meters. So 1 cm represents 200 meters. Now it is easier for us to do the multiplication. Times 4. So here we also times 4. So both sides times 4. 1 cm times 4 gives me 4 cm. So distance will be 4 cm. Right, any questions for this? Okay, now I think the last question for our holiday homework. Wow, it's Thursday already. 1 cm to 40 kilometers. Okay, I see area. So I have to be very careful now. Map. Actual. Now we are talking about length. 1 cm, 40 kilometers. So now we want area. From length to area, we will need to square everything. Every single thing. 1 square cm square. 40 square km square. Now this is the ratio of our area. So this is simplified to become 1 square centimeters to 1,600 square kilometers. This is what I need to see before you are given 1 mark. To show me that you know how to convert from ratio of length to ratio of area, you need to square everything, not just the unit, the number you also just square it. So now they tell us area of 2 square centimeters on a map, 2 square centimeters. So to go from 1 to 2, multiply by 2. Multiply by 2. So the actual area will be 3,200 square kilometers. Actual. And then in part B, actual area 2,000 square kilometers. Map. Actual. So we are still talking about the area. 1 square centimeter to 1,600 square kilometers. So since we require our 2,000. So if you do not know, what should we do? Then you can go down to 1 square kilometer first. Okay, 1 square kilometer. So here you divide by 1,600. So you will also need to divide by 1,600. Then after you have 1 square kilometer, then you multiply by 2,000. Then the next one, multiply by 2,000. So what do we have? 1 over 1,600 cm square. Then we multiply by 2,000, we get 2,000 over 1,600. And then we simplify this to become 5 over 4, 1.25. Area on map, 1.25. 2,000 divided by 1,600, then what do you do? Then that number on the other side is times that whatever you just got right. Can. Yes. 1 and 1/4 can. Same.